All right, today we are diving into something, well, something pretty mind-bending from the world of theoretical physics. We're talking about a new model that doesn't just nudge our understanding of the universe. Oh no, it suggests we should just erase one of its most fundamental yet undiscovered building blocks.
So what if a fundamental particle of physics just doesn't exist? I mean, really think about that. Imagine you spent decades, your whole career, looking for this one key piece of a puzzle, the piece that's supposed to make everything click. And then someone comes along and says, hey, you know that piece you're looking for? It was never in the box. That's the wild idea we're exploring today. What if a particle we all assume has to be there just isn't?
Okay, so let's get into it. The gravity puzzle. Now, to really get why this new idea is so huge, we've got to first understand the massive problem it's trying to fix, a puzzle that has, frankly, been driving physicists crazy for almost 100 years.
You see, at the very heart of modern physics, there's this epic clash of titans. On one side, you've got Einstein's general relativity. It's beautiful. It describes the universe of the really big stuff, planets, galaxies, and tells us gravity is just the bending of space-time. Then, on the other side, you've got quantum mechanics. This is the king of the super small, describing particles and forces. And here, forces are all about little messenger particles being exchanged back and forth. Now here's the problem. Both of these theories are rock solid, absolutely brilliant in their own worlds. But when you try to make them work together, say in the center of a black hole, they just don't. They give you answers that are complete nonsense. It's a huge problem.
So, for decades, the conventional thinking has been, okay, let's make gravity play by quantum rules. The solution? Let's invent a hypothetical particle called the graviton. This little guy would be the messenger for gravity, just like photons are for light. It's a neat idea, right? It would solve everything. There's just one tiny little problem. After all this time, nobody's ever found one. Not a single trace.
Which brings us to a particle that maybe isn't there. This is where this new model throws a massive curveball. It asks a really provocative question. What if the reason we can't find the graviton isn't that our gear isn't good enough? What if it's because we're on a wild goose chase for something that just isn't there to begin with?
And here it is, the central claim, laid out as plainly as you can get. The graviton does not exist. Just let that sink in for a second. This is a huge statement. It basically says that this decades-long search for a quantum theory of gravity has been built on a faulty assumption. It's saying the graviton isn't just hiding, it's completely unnecessary.
So you might be asking, why? How could it be unnecessary? Well, the logic is actually pretty elegant. The model asks us to completely change how we picture the universe. Instead of seeing it as a bunch of separate things, planets, stars, people, floating in empty space, what if it's all one single continuous thing, a seamless fabric of reality? If that's true, then you don't need a messenger particle. Think about it. If you pull on one corner of a blanket, you don't need to send a pull particle to the other corner to tell it to move. The whole blanket just moves. The interaction is a property of the fabric itself.
Okay, so if we're tossing out the graviton, what's the alternative? Well, this is where we get to the really cool part. We get to build a whole new picture of the cosmos, all based on this idea of a single fabric of reality.
In this new way of looking at things, it's all connected. Gravity? That's not a force carried by a particle. It's just the overall shape of this fabric of reality on the grandest scales. What about the other forces? Well, those are just tiny, quantized wrinkles within that same fabric. And what about particles themselves, the stuff we're all made of? Those are just stable, localized shapes, like little persistent knots in the fabric. You see? It's all just one thing, manifesting in different ways.
And this idea of a wrinkle is really the key to the whole thing. A wrinkle is a localized, quantized shape in the fabric of reality, which we perceive as forces and particles. And it's so important to get this. The wrinkle isn't something on the fabric. It is the fabric, just behaving in a particular way in a certain spot. It's an inherent property of the fabric structure itself, not some little speck you can just pick off.
Let's talk about what this all means, because the implications are pretty mind-blowing. We're talking about one unified reality. If this model is right, it doesn't just neatly solve the gravity puzzle. It completely rewrites the rules for what it even means to unify physics.
And here is the biggest bombshell of all. In this model, how many force-carrying particles do you need? 0. That's right, a big fat 0. The model doesn't just kick out the graviton, it kicks out the entire concept of a messenger particle.
Yep, you heard that right. This applies to all of them. Photons, gluons, the W and Z bosons, they're all reimagined. They're not separate particles flying around anymore. Instead, they're just different kinds of wrinkles moving through the fabric. So when our detectors go bing and we say we found a particle, what we're really seeing is just one of these localized shapes passing by.
And honestly, this might be the most beautiful part of the whole concept. See, most theories of everything are about unification, trying to find the one common ingredient that everything is made of. But this model says that's the wrong way to look at it. This isn't about unification of parts. It's about recognizing a pre-existing unity. It's saying there are no separate parts to unify. Space-time, matter, forces, they aren't just made of the same stuff. They are the same stuff, just different expressions of it.
So what's next for physics? Now, of course, an idea this big and bold is, for now, a conceptual framework. It's a beautiful picture. But how do you turn that picture into a real, testable scientific theory?
Well, the path forward is pretty clear, but it's going to be tough. Step 1 is the really hard part. You have to develop the math. You've got to translate this elegant concept into a set of predictive, testable equations. After that comes the ultimate challenge. Can this math, can the properties of these wrinkles actually reproduce everything we already know? Can you derive the standard model of particle physics from it? Because if you can do that, wow, that's not just a new theory, that is a full-blown revolution.
And that really leaves us with a huge question to ponder. Is the universe a collection of separate parts, or is it one single thing? Is reality fundamentally a box full of tiny, separate billiard balls bouncing off each other? Or is it, and has it always been, one single, unified, indivisible whole? Something to think about. Thanks for joining me.